Okay, this is the first video tutorial. It is on the topic of significant figures. Or just we'll call them sig figs, or sometimes they're called significant digits. Significant figures is important when you're doing calculations. It essentially indicates when you take your basic measurements, okay, and you carry out a calculation, where do I round it to? The best way of illustrating this is with an example. So if you're doing a density calculation, you know density is equal to mass divided by volume. And let's say the mass of the sample of matter that you're measuring is 2.0 grams, and the volume of that sample of matter is 3.00 milliliters. Well, your calculator is going to spit out 0.6666, and it's a repeater. Well, how accurate is the measurement? Do you really know the density of the sample of matter to the hundredths place, or to the thousandths place, or the 10,000ths place? Well, significant figures gives you an indicator of how accurate your measurements were, and how accurate your measurements are determines how accurate the result of the calculation is. So in this particular example, 2.0 grams has two significant digits. 3.00 has three significant digits. And the general rule is when you're doing multiplication or division, right, whichever one is your least accurate measurement is going to determine what you're going to round to. Since this measurement is your least accurate, you're going to round this so it has two significant digits, which means you're going to stop this guy right here. You're going to go from left to right, you're going to pause right there, and then you're going to look one place over for rounding purposes. You're allowed to go one place beyond what is considered significant for rounding purposes. So your answer here will be 0.67 grams per milliliter. Now the goal of this video is not to do calculations. I'm going to put that into a second video. All I want you to understand in this video is how to determine the number of significant figures. So Roman numeral 2 is determining sig figs. Now, this is important within the context of measurement. And the bottom line of this is, if it's a non-zero, this is like rule number 1. Okay, a non-zero is always measured, and therefore it's always significant. I'll just put an S whenever something's significant here. Okay? Now, supposing you have a graduated cylinder, right? And you're eyeballing your graduated cylinder, and there's a meniscus in there like this. And this says 100, and this says 200, and you're trying to figure out what is the volume in the graduated cylinder. Well, the basic rule of measurement is you're allowed to have one uncertain or estimated digit, but that means sometimes you're going to have a zero that actually wasn't measured. So in example number 1, which is the one we're doing now, you would say this is between 100 and 200, so we're certain of the hundreds place. And then we look at this thing, we look at the bottom of the meniscus, okay? And we'd be like, that looks about right in the middle. So we'll say it's about 115. Now we couldn't put 15, we put 150, but we really don't know anything about this place. We're absolutely certain about this one. We estimated this one, and we know nothing about that. Which leads to another rule. If you put this thing into scientific notation, you get 1.5 times 10 to the second power. A zero that's not significant will always disappear when you put something into scientific notation. That means a zero that's not really measured, that we really don't know anything about. So here's rule number 2. Rule number 2 states trailing zeros in the absence of a decimal are not significant. That's what the NS is going to stand for, not significant. So we have two rules so far. Let's try another example. Here's another example. I'm hand drawing this, so it's not going to be as good. I'm going to pause. Alright, so I've just put in two other examples to illustrate the final two rules. So if we measure for this one, we're going to put down, it's definitely 0.1, we're sure of the tenths place. It's definitely 0.1, it's definitely not 0.2. And if we look at this meniscus, it's sort of right here on the line. So we could say this is 0.10 milliliters. Now if we put that in scientific notation, this 0 is going to stay, because that's an estimated 0. We're not sure, it's 0.10 approximately, but that estimated digit is considered to be significant. And therefore, if we put this in scientific notation, we're going to write 1.0 times 10 to the negative 1 milliliters, and that 0 will stay. And so the rule number 3 is that a trailing 0 counts if a decimal is present. And the final rule, rule number 4, deals with what I call leading zeros. Now, if you're not understanding leading and trailing, I'm considering zeros that are in the front, okay, like in the number, like when I measure this is going to be 0.0001, maybe 4. These are leading. Leading means they're to the left, if that helps. Trailing is going to be the right. So leading zeros, and this is very easy, these zeros just never count. So rule number 4, leading zeros are basically not significant. So I'm just going to do a couple of quick examples, and then I'm going to give you a few to practice. And then we'll talk about situations in which it's a little more complex than the Regents level. All right, so if we have a 0.01, since this is a leading 0, it doesn't count. This has 1 sig fig. If I do 0.010, this is a leading 0. It still never counts. This is a trailing 0. Now, trailing zeros count if there's a decimal. Since it's decimal, this has 2 sig figs. If I have a number like this, 1.01, zeros that are in the middle always count. So that has 3 sig figs. And non-zeros are always counting. If you have a number like this, 0.0001010, it's a little more complicated. These are leading. They don't count. This one's a middle one. That counts. And this one is a trailer, and there is a decimal present, so this one doesn't in fact count. So this one would have 4 significant digits. All right, what I'm going to do is put up a couple for you to try, and then I'll give you the answers. Okay, I'm going to tell you to pause here and see if you can get them right, and then I'm going to then unpause and you'll see the answers. All right, I'm going to explain each of these. For A, there's no zeros here, and this has nothing to do with significant figures. What's important is there's 3 significant digits there, and that's all that matters. This is a leading 0 right there. It does not count, so we count the 7 and we count the 6. That's 2 significant digits. This is a leading 0 as well. It still doesn't count. There's a decimal present, so any trailers do count. So this 0 right here does in fact count. So this has 3 sig figs, the 7, the 6, and this trailing 0 with the decimal. For D, this has 2 zeros. These are considered trailers. Trailers are to the right of a non-zero. So these are trailers, and there is no decimal present. And for that reason, there's only 1 significant digit. However, in this case, E, which I put in there right afterwards for a reason, there are in fact 4 significant figures because there are 3 trailing zeros, but because there's a decimal present, that means that 0, all those zeros were actually measured. This is a middle 0. Middle zeros always count, and so the 7s and the 0 in the middle count. That's 3. And these are leading zeros. 4 leading zeros are zeros to the left of the non-zeros. means one significant digit.